In motion in 2 or 3 dimensions, we defined the radial vector as the x component times I hat plus y times j hat, and we said the displacement is delta r, which is r minus r naught, meaning from r naught to r. And if you did put the 0 in here for r naught, and that, if you subtract, you get delta r equal to the same if you have 3 dimension, z minus z naught k hat, and that's displacement. Graphically, of course, is, let's say this is r naught, and the object is moving on a path like this. Go from r naught vector, which is right here, to r. Sorry, r vector, which is in here, and delta r will be this vector from r naught to r. And then we define average velocity vector. The average vector is the delta r over delta t. Delta r over delta t. And then when we let delta t goes to 0, take the limit of this, we call it instantaneous velocity. So instantaneous velocity is a limit of delta r over delta t as delta t goes to 0. And velocity vector then has 2 components. If we call the components vx, and the y component of it we call vy, and z component is vz k hat. Then vx is simply dx over dt, and vy is dy over dt, and dz is equal to dz over dt. This is simply as we had before. In a similar fashion, we also define average acceleration and instantaneous acceleration. The acceleration also has components. I just write 2 dimension. If you have the 3rd dimension, you can extend it easily. Just add another dimension to that. And ax, it is dvx over dt. And that is equal to, if you use vx as dx over dt, this is second derivative of x with respect to time. And ay is dvy over dt, is the derivative of vy with respect to time, which is second derivative of y with respect to time. But these are important formulas for us. And something that's important to see here is that these x and y do not mix up. Everywhere you have x, it's just x. There's no y in the x formula. There's no x in the y formulas. That separates x and y completely. So if the acceleration is constant, if acceleration in x direction or y direction is constant, then we do the same thing as we did for 1 dimension. We can write all those kinematics formulas that was for constant acceleration. So if ax and ay are constant, we can write all those formulas for constant acceleration we had. So we have vx, for example, equal to v naught x plus ax times t. Remember this? And then x itself is equal to initial value for x plus v naught x times t plus 1/2 ax t squared. And we have vx squared equal to v naught x squared plus 2ax x minus x naught. Usually we use these three equations. And then for the y direction, again, the same three equations. Just change every x to y. We have similar equations for the y direction. They work perfectly the same way. I just don't have time to write it, just the same for y. In particular, if the acceleration is if the acceleration vector is the acceleration due to gravity, which is downward, and its magnitude is, what's the magnitude? 9.8, or we call it g, right? So we can say negative g, j hat, right? If the acceleration is this, that means that ax is 0 and ay is negative g. Right? If you have acceleration in x direction 0, then for all of these equations, you see, if you put ax equal to 0, it just gives you v in the x direction, doesn't change. Right? This one says x is equal to x naught plus initial velocity in x direction times t. So we have that. Let me write this down. X equal to x naught plus v naught x times t. Right? And if put ax equal to 0 here, again, this term goes away. You have the x equal to v naught x. Right? So it doesn't give you anything else. It's just the x is equal to v naught x, and then we have only this equation for the x direction. And then because ay is negative g in y direction, we have all these equations for y with acceleration replaced by negative g. So we have dy equal to v naught y minus gt y equal to y naught plus v naught y t minus 1/2 gt squared, and we have vy squared equal to v naught y squared minus 2g delta y. You see, we have these three equations for the y direction and only one equation for the x direction. That solves all the problems involving projectile motion that we consider acceleration to be only in negative y direction and constant. Of course, when we say acceleration in y direction is negative g, means that the y direction is upward, and that's our usual condition. We take y always upward and x to the right. All right, so we also applied this to a specific situation. Let's say I launch a ball vertically upward with v naught, and it goes to this height, which is 1.2 meters. And that's the highest it goes. So what is v naught? How can I solve for v naught? Who remembers? What are the steps to take?
Well, you know y1 and y0 and acceleration.
I don't know y and y0 unless I have a coordinate axis, right? So first you draw a picture like that, and then put a coordinate axis here, and say, okay, this goes from here to here. I take this as my initial situation, this as final, right? And our x-axis is here, means that y initial is 0. Y final is h, which is 1.2 meters. Make this your habit of setting up the problem so that you don't make a mistake. So I have initial position, I have final position, I know the acceleration is negative g, so this set of equations would work for y direction. And then what do I know about the speed here?
0.
0, yes, because it has highest point, the Vy will be 0, and I want V0. What is missing in that list as unknown or known?
Time.
Time. See, there's no mention of time. We don't know it and we don't want it. So time is missing, so the equation that doesn't have time in it will solve the problem. So we go Vy squared equal to V0 y squared minus 2g y minus y0. And also, this is my habit. You see, even though the equation is right here, I copy it here so that I know what I'm doing. Now, I throw everything that is 0 away. So Vy is 0, and y0 is 0. You call it y0. Right? And then you can simplify this and solve it for V0. So V0, if I move this over, V0 y squared, which is the same as V0, equal to 2gh. And V0 is equal to square root of 2gh. Right? And because V0 is the magnitude of velocity, right? But because the angle is 90 degrees to the x-axis, it has only one component, Vy. And the component is equal to its magnitude. That's why I put V0 y equal to V0 magnitude and equal to 2gh. Now I can put the numbers in. That V0 equal to square root of 2 times 9.8 meters per second squared. Let me put the units as well, times h, which is 1.2 meters. Right, the value will be 2 times, almost 10 times 1.2, about 24, right? And then the unit will be meter times meter divided by second squared. It will be meters squared per second squared, but it is under square root, becomes meters per second. And what is the number? If
4.85.
yes, thank you. We not equal to 4.85 85 meters per second. This is how we can find the initial velocity. That is the speed that this launcher launches the ball. Now we want to put it in a different angle. Let's, for example, put that at a 50-degree angle. Now if I do that again, it launches the ball with this speed, but at an angle, right? So let's see how far it will go in the horizontal direction until it hits the floor. If I copy this in here, the situation, this is the launcher, and it is at angle 50 degrees, and the ball is in here, and then it shoots the ball over until it gets to the ground, like that. I need to know initial height. I can measure the initial height in here. So now this height is 120. 1.2 meters from the floor. The floor is horizontal, and its initial speed is this way at 50-degree angle to the horizontal, and has the value of 4.85. Right? Now I want to find this distance, how far it goes to hit the floor. What do I do?
First thing I would do is V naught x equals 4.85 cosine 50, and then V naught y equals that.
That's good. You have in your mind what?
The coordinate system?
Coordinate. You have in your mind the coordinate system already. So let's make it official. You have an x direction this way and y direction that way, right? That was in your mind. But it is, let's do that. And of course, we need an initial and final. This is our initial situation. This is final situation. Right? Now let's find everything that we know about the initial situation and final situation. We mentioned that the initial velocity in x direction, v naught x, is v naught times cosine 50, right?
Mm-hmm.
Is v naught cosine theta naught. Theta naught is 50. So V naught x is what? Multiply 4.85 by cosine 50. What do we get?
3.12.
3.1. What?
Well, what was our velocity now for V naught?
V naught is the speed at which in the previous
Oh, it's the same.
test,
Oh,
yeah.
it's the same. Okay.
Yeah, if it launches the ball with the same speed, then that is now in this direction will be the magnitude of the velocity at the beginning, which is the V naught. So V naught is what we found before, 4.85. And then multiply by cosine of 50, you get 3.12 meter per second. And V naught y
3.72.
is V naught sine theta naught, or 4.85 sine of 50. What did you say? 3.72.
72.
Thank you. Meters per second. All right. So now we know these values about initial situation. Be careful that these are different from V naught magnitude. Right? It's not 4.85. That 4.85 is the magnitude of velocity, but it has two components. Each component is smaller than that, right? So these are about the initial velocities. Do we know initial position?
Yeah. X is 0.
Yes, x naught is 0.
Y is h.
Yes, y naught is h, which is 1.2 meters. Right, in this coordinate system. So you could just read it from the coordinate system. Right? If you are here, x is 0, y is 1.2. Right? And so you have initial position and initial velocity in each direction. And you want to find this d. What is d in
X.
x final, right? So x is equal to d. Let me write it here. X is equal to d, which we want to find. And what do you know about y?
0.
Y is 0. So the xy origin is here. At this point, the y coordinate is 0. Right? And then, what else do we know? Do we know
AX is
anything?
0.
Sorry?
AX is 0.
AX is 0, yes.
And AY is negative G.
AY is negative G. Means that we have these two equations, this equation for x and this set of equation for y. So now if I want to find x, I can go to my list of equations, see where x is, right? Where is x? The only place we have x is here. So x is x naught plus v naught x times t.
But we don't have time.
Yes. You see, x naught is 0. This is 0. V naught x is 3.12, but we need the time to find x. There's no other equation to help us, so we have to find the time. So we have x equal to v naught x times t, but we need to find time. So what is t? The problem reduces to finding t, right? And then now with these parameter values that we have, how can we find t? So let's go through our equation, see which one will help us. Vy equal to v naught y minus gt. Can we use that to find t? If we use this, we need to know everything else, right? Especially vy. What is this vy? Vy is the final velocity in y direction. Do you know that?
Should be 0, right?
Is it, this is moving this way, right?
Yeah.
When it's moving downward, Vy is not 0, and we don't know how much it is. So we cannot use that. What about this one? This one we cannot use because there's no time in it, right?
We can use that one, the second one.
The second one.
Mm-hmm.
The second one, we have initial final position, initial velocity in y direction, and g, everything is known except t. So that's what we need to use. So we write y equal to y0 plus v naught yt minus 1/2 gt squared. Which ones are 0? Y is 0, we throw this away. So put 0, now plug in numbers. Y naught is 1.2 plus v naught y is 3.772 t. 9.8 divided by 2 is 4.9 t squared. I usually like to have a factor of t squared as positive, so I try to multiply everything by a negative sign. 4.9 t squared minus 3.72 t plus minus 1.2 equal to 0. And then this is a quadratic equation. Everyone knows how to find the answer. This becomes negative b plus or minus square root of 3.72 squared minus 4ac. 4 times this, 19.6 times 1.2. That's the 24 something, 3 something. 19.6 times 1.2. How much is that? Divide by 2a, which is 9.8. You get one positive value, sorry, this becomes negative and negative positive. You get one positive value, one negative value. Right? We are interested in positive time.
1.00.
1 second. Everyone did the same? 1.00. That's very coincidental.
Yeah.
Seconds. And now that you have the time, you can go back to the x direction. X equal to v naught x times t. X, which is b, equal to v naught x times t. So x becomes 1 second times v naught x, which is 3.12. So 3.12 meters.